friends, welcome back to our channel Physics Tutorial. Today we are going to continue with the continuation of 14th chapter of plus 2 physics, that is semiconductor electronics. So in the last class we had discussed the types of semiconductors, that means extrinsic and intrinsic semiconductors. That means in the case of extrinsic semiconductors we have already discussed p-type and n-type semiconductors. Okay, hope it was clear to you. Now we can move to the continuation of that, that is a very important topic that you have to know is p-n junction. So that is very important in electronics. So whenever we study electronics, that is even in higher classes, these are the basic things that you should know about electronics. So these are the basic concepts that you have to understand clearly. So please don't try to by heart the things. You can understand the things, then it will be more easy to study. Okay. So now we can move to the first topic, that is p-n junction. Today p and n type semiconductors we have already discussed, right? Now we have to know what is the p-n junction, and this p-n junction is actually the basic building block of semiconductor devices such as diodes, transistors, etc. So these are the basic building blocks, means whenever we are going to study about diodes or transistors, this concept you have to understand. What is a p-n junction and how the p-n junction is formed, and how the flow of electrons and the electric current is generated. All these things, the basic principles behind p-n junction is very important and that you have to understand. Okay, so now we can see what is a p-n junction. p-n junction is, here we can see a crystal. Here a p-type semiconductor is there, n-type semiconductor is there. When we combine these two, that is p-type semiconductor and n-type semiconductor, if we join or combine to make a single crystal, we can call it as a p-n junction. So p-n junction is actually the junction at which a p-type and n-type semiconductors combine, is called a p-n junction. There are different methods for forming p-n junctions. Here we can see a p-type and n-type materials are combined to form a p-n junction. Otherwise, we can take a p-type semiconductor like silicon or something. So p-type semiconductor we are taking, and we have already suppose this whole thing is p-type material, and now we have to make an n region, right? For that, what we can do is, here on the center we have to add some impurities, because in this side we have to add some pentavalent impurities. Then that will be n-type, then it will form a p-n junction. Clear? That means the whole thing we can take as the single p-type material. Okay, and then half of that we can make n-type by adding some pentavalent impurities. So like that we can do. So there are different methods we can use for forming a p-n junction. So just to understand that p-n junction is the junction at which the p-type and n-type semiconductors combine. It is called a p-n junction. Clear? And now we have to know the formation of p-n junction. So there are two processes happening in the p-n junction formation. The first one is diffusion and the second one is drift. So first of all, we have to know that what is diffusion and what is the drift. After that, we have to move to the process. So diffusion means the movement due to the variation in concentration. So here in chemistry we might have heard about diffusion, right? Due to the variation in concentration, the movement will happen, right? Here also, due to the variation in the electrons and holes concentration, only the concentration in the electrons or holes, the diffusion will be taking place here. Here we can understand that in p-type the holes will be the majority charge carriers. That means more number of holes will be in this p region and more number of electrons will be there in the n region. Then what will happen, if n region is having more electrons will be diffusing from n region to p region, or the holes will be diffusing from p region to n region. That is called diffusion. Okay, so due to this diffusion current will be formed. Diffusion current means due to this diffusion, the current will be flowing through that, and the direction will be determined as usual, because if the negative charges are, if we are taking the flow of electrons, what will happen? The direction will be just opposite to the movement of electrons, right? Or if you are taking the movement of holes, that means positive charges, means the direction of current will be in the same direction of positive charges. Okay, so that direction we can find by using that, and that is called diffusion. Diffusion means movement due to the variation in concentration. So here from n side, what will happen? The electrons will be moving to p side, and in p side the holes will be moving to n side. So that is called diffusion. And drift is movement due to change in electric field. So here the electric field will be set up. So we have seen that these electrons and holes will be moving to both sides, and here a barrier will be formed and electric field will be set up here. So that we will discuss in detail, and then an electric field will be formed. So due to that change in electric field, a drift also happens. So that is the second process that happens in p-n junction. So we can discuss how the p-n junction is formed here. Okay, and we can see that initially here there will be nothing, right? Only p region is here, only the n region is here. So what will happen here? Electrons will start to move to p side, because here holes are there. Then this electrons will be easy to flow to this p side. So here we can see what will happen here in n side, because n is that pentavalent impurities are added here in n-type material, right? So suppose we are taking arsenic as the pentavalent impurity. So what will happen here? That 4 electrons will be bonded with that arsenic, with the silicon, right? The one extra electron will be moving to this p side. So what happens if one electron is losing from here, means this n, that means arsenic will be becoming the arsenic ion. Okay, so that will be immovable. That means it will not be able to move, because ions are not able to move. So here that arsenic ions will be formed. In similar way, more electrons will be moved from arsenic, and that ions are forming here. So this will not be able to move. Okay, so these ions will be formed here, that because this is a positive charge and it will have a tendency to move to the positive side, right? So here a layer is formed like this. And in the p region, what will happen? Suppose here we know that in p type the material is trivalent impurity. Okay, trivalent impurity we are adding to this p type material to get the p type material. So suppose it is boron. So in the case of boron, what will happen? There will be a deficiency of electron, right? So that will accept one electron, that we have already discussed in the last class. So that will accept one electron means that will be, yes, here holes will be created, right? So this will be becoming positive, this positive charges will be moving to n side. So that is forming a layer here in this n region. And suppose the process is increasing, what will happen? If it continues, what will happen? More number of electrons and more number, like this, negative charges and more number of positive charges on the other side will be formed. Okay, this is negative charge and this is also negative charge. Here we can see this positive charges will be more, positive charges will be formed here in this side. So the layer width will be increased. Okay, so what will happen? After increasing this width, if another electron is coming from n region, what will happen? This will have a tendency to oppose the, yes, electrons. Okay, so that will not allow all the electrons to pass through the region. So some electrons only will be able to pass through this. So here also in the same thing will happen, right? Because here it is positive charge and this will oppose the more positive charges to pass through this region. And here we can see a region that will be free, that means mobile charge free region will be formed here. This will be mobile charge free region. Free region means there will not be any moving electrons or holes, okay, because charges will not be able to move. That is called mobile charge. Mobile charge means moving charges. Free means it is not able to move. So mobile charge free region will be formed here, and this is called depletion layer or depletion layer, means region or depletion junction. So this is called depletion region. Here we can see this region is called depletion region. Clear? And now after forming this depletion region, what will happen? The number of electrons will be decreased whenever that diffusion rate will be decreased, because this barrier will not allow all the electrons to pass through this, and in the similar way it will not allow all the holes to cross through this layer. Okay, so what will happen here? The diffusion current will be decreased. Now this will be equivalent to, this negative charges will be equivalent to the negative of the cell, and this positive charges will be equivalent to the positive of the cell. That means it will act as a cell here. So what will happen here? Yes, a drift current happens. That is how the second process is happening, due to this electric field. Right here an electric field is set up now, and due to that the movement of charges will be happening. So what will happen here? Here we are connecting to a negative charge, then here positive charge we are connecting, right? So due to this negative charges, here that minority charge carriers will be electrons, right? So that will be able to cross through this. So due to this minority charge carriers, what will happen here? Drift current is formed. So that idea you have to understand. Here also we are adding in N region, we are giving this positive cell, right? So here this holes will be able to cross this, right, because of this drift current. So here drift current will be formed, and only due to minority charge carriers the flow of electrons and flow of holes will be happening. So here we can see the direction of electron drift. Electron will be drifting from this portion to N region. That is why here the direction is shown here, and hole diffusion was happening like this. Okay, hole diffusion means holes from P region was moving to N region, and hole drift will be in the opposite direction. Clear? Hole drifting means from this region the holes will be drifting. So only because of that electric field that drifting happens. And now what will happen? Yes, the electrons will, that means from P region to N region the electrons will be drifted, and from N region to P region the holes will be drifted. That are the minority charge carriers here. So as the process continues, what will happen? Diffusion current will be decreased, because after reaching this a maximum value of depletion region, what will happen? It will not allow any more electrons to cross through this region, and holes also to go to this N region, right? So here drift current increases and the diffusion current will be decreased, and after some time what will happen is this drift current and diffusion current will be equal, and that means then there will be no flow of current. So that is called the PN junction. Then we can say that a PN junction is formed here. So there will be no more flow of current. Okay, so that is called a PN junction. So you have to just understand the concept, how it is flowing, what is happening inside a PN junction. Right. So here first thing that you have to remember is, here in P region the majority charge carriers is holes, and here N is the minority charge carriers, and diffusion is happening due to this majority charge carriers, right? So from N region the electrons will be flowing to P region, and from P region holes will be moving to N region. That was happening in the case of diffusion, and as the depletion region increases its width, what will happen? It will not allow this process. So that means the diffusion current decreases, and then it will be just equivalent to the cell. So that means here we have negative charge and this is the positive charge. Okay, so due to minority charge carriers the drift current will be flowing. Okay, so hole drift is here and electron drift is shown here. So that will be just opposite to the diffusion current. And here we can see that after some time, what will happen? Both the currents, diffusion and drift, will be equal, and in such a case there will be no flow of current. So that then we can say that a PN junction is formed. So this is very important. And one more thing is that a potential barrier will be developed here, right? That we have already told, and that potential barrier depends upon the material on which we are taking for doping. Okay, suppose we are taking silicon, then that potential barrier will be 0.7. So for moving the electrons or holes, because for getting a current we have to give more than 0.7 electron volt. Okay, then only it will move, the electrons and holes will be flowing through that, because the potential barrier value for silicon is 0.7 and for germanium that value is 0.3. in some textbook we can see that it is 0.2. so both we can consider 0.2 or 0.3. actually it is 0. near to 0.3. then if it is 0.2 is given in your textbook, it's okay, right? Then that readings, that values you have to remember. So this means the region will have 0.7. that means if we are giving more than 0.7, that electrons can cross the region and come to P region, right? So that potential barrier for silicon is 0.7, and for germanium, silicon it is 0.7, and for germanium it is 0.3. okay, so these two readings also you have to remember. So this is all about PN junction. If you have a clear idea about this, then it will be more easy to understand the PN junction diode, that means biasing. So there are two types of biasing that we will discuss now. Now we have to study about semiconductor diodes. Semiconductor diodes means that is actually PN junction diodes. Semiconductor diodes are the PN junction diodes. So we have to understand that the function of PN junctions. Then only we can explain the working of a semiconductor diode. That means biasing also we have to learn in this session. So here we have a semiconductor diode. This is the symbol of a semiconductor diode. So this positive and negative, just I have mentioned here, it is not compulsory to write this. Here we can see that this side is positive and this bar is negative. So this is the symbol of a semiconductor diode. So we can connect this semiconductor diode in two ways. First one is forward biasing and the second one is reverse biasing. So I have told that this is the positive side and this is the negative side. So biasing I will just explain. Biasing means if you are connecting that into a circuit, we can call it as biasing. So if we connect a semiconductor diode in a circuit, that is called biasing. So first of all we can do forward biasing. In the case of forward biasing, here we can see this is the positive side and this is the negative side of the diode, right? Semiconductor diode. So here this positive side is connected to positive of the cell and negative side is connected to negative of the cell. Such a biasing is called forward biasing. So P to P and N to N, like that you have to remember, because positive to positive and negative to negative, right? So this is called forward biasing. In such a case there will be current flowing in the circuit. And here reverse biasing is just opposite to that. Here we can see this is the semiconductor diode and we are connecting this positive to negative of the cell and negative to positive side. Okay, so this is called reverse biasing and there will be no current flowing in this reverse biasing, that we will explain in detail. So just to understand this, how we are connecting in a forward biasing and in a reverse biasing. So in forward biasing, the positive of the side is connected to positive of the cell and negative to negative. So now we can explain this forward biasing in detail. So here we can use a PN junction diode, because semiconductor diode is the PN junction diode itself, that we have already told, right? So we can draw this. This is the PN junction, right? So here P is there and here N is there, and due to this diffusion and current and drift current that we have already discussed, right? So that you have to keep in your mind, then it will be easy to understand the concept. Here that due to this negative charges, here immobile charges will be formed, a barrier will be formed here, that all things we have told, right? So here electrons will be majority carriers in N region and holes will be majority charge carriers in P region, right? So this electrons will be moving to P side and it will form a barrier here, a junction here, and this from P side the holes will be moving to N side. So here we have positive charges, right? So this positive and negative charges, they are immovable ions, and there we have told that a drift current will be produced here. Okay, so diffusion current was there initially, and after that it was decreased and a drift current was produced. So due to that drift current, this electrons will not be able to cross this junction, that we have told, no? And for if we are taking this crystal as silicon, suppose the silicon we are taken here, so the potential barrier will be 0.7. that means we have to apply a voltage more than 0.7 for crossing this electrons from N side to P side. Clear? And now we are connecting this in forward bias. So what will happen here? This P side is connected to positive and N side is connected to negative. So here we can see this positive means here we have more number of holes, so that is positive charge. So this positive charge will automatically repel this side, and here we are giving a voltage or a potential more than 0.7 volt. So what will happen here? This side will be acting as the positive charge, and this negative side will be, this negative will be coming here. So this will be acting as the negative charge. Understand it clearly. So what will happen here? This positive charge will be repelled by this positive charges, right? Here we have majority charge carriers are positive, so this will be repelling this positive charge, and here also what will happen? This negative charge, here the majority is negative, so that will repel this negative charge. Okay, so suppose we are giving a potential more than 0.7, what will happen? This will be able to cross this barrier. Okay, so in the case of silicon only we have to take more than 0.7. If we are taking germanium, it should be more than 0.3 only, or more than 0.2. It's like that. Okay, so here we are taking the silicon, and we are taking the potential as, or voltage as more than 0.7. So what will happen? This electrons, right, that will be able to cross this barrier. So from here the electrons will be able to cross the barrier, and here positive charges will be here, right? So positive charges are here means that will be able to cross this barrier. So like this, the electrons will be moving to this side. Okay, so these electrons will be moving here, that will cross through this side and will reach here. Okay, and here what will happen? These holes will be moving to opposite side like this. Okay, because this will be able to cross this barrier and will move through this, then the current flow will be possible. So current flows through the circuit. So that is the case of a semiconductor, that means forward biasing. PN junction diode is forward biased, means that current will flow through the circuit. Clear? So this holes will be moving to this opposite side, that means that will attract this negative side. Clear? And this electrons will be moving through this barrier and will reach here, then the current flow will be happening there, right? So that is how the current will be flowing in a forward biased case. Now we have to see what will happen if it is reverse biased. And one more thing we can see is the diagram of this. So suppose here we are taking a IV graph. Here current is taken along y-axis and voltage along x-axis. Here current, and here we are taking the voltage. Then we can see that initially there will be no current, and after getting that 0.7 volt, what will happen? This current will be increased. So this is the shape of a graph. Okay, that is called IV characteristics. And so just to understand that before till 0.7 volt there will be no current in this circuit, and after 0.7 we can see an increase in current. Okay, so this is the shape of the graph, and that is the case of forward biasing. Now we can see how we can connect in reverse bias. Now we have to connect the PN junction diode under reverse biasing. So here we have already told that in the case of reverse biasing, we will connect the negative terminal of the battery to this positive P side, and positive side of the battery to to the N side. Okay, so that P side is connected to negative and N side is connected to positive. So here also we can assume that we are considering the silicon. Okay, so the material is silicon and the potential barrier will be 0.7. And in the previous case we have told that when we were doing that forward biasing, we were getting the current as milliamperes because that majority charge carriers were the reason for getting the electric current. Okay, so here they were getting milliampere, that means high current we were getting. And in this case we can see what will happen. So here as we have told, PN junction is there, and from N that electrons will be moving to this P side, and from P side the holes will be moving to this N side. Okay, so that we have already told, no, diffusion current was there, and this negative charges and positive charges will be formed here. And when we give the biasing, what will happen? When we connect this to the cell, what will happen here? Here we are connecting this negative of the cell to P side and positive to N side. So here the negative charge will be here. Okay, the negative charge that will be coming here. Then what will happen? P region is having positive charges as the majority charge carriers. That means holes are the majority charge carriers in P side. So what will happen? This holes will be moving to this side. Okay, so here the charges will move, and in this side what will happen? Here electrons are the majority charge carriers, and that will move to the positive side. Here this side will be positive, right? So this will be moving to positive side. That means no electron or hole will cross the barrier, so that the barrier strength will be increased and there will be no current flow due to majority charge carriers. So majority charge carriers are not at all crossing this barrier, because this negative charge will attract this positive charge, and this positive charge will attract the negative charge from the N side. But we have already told that drift current will be here, right? This will act as a electric, means this is equivalent to a cell, and here drift current will be formed, and that drift current is due to the minority charge carriers. So here we know that in P side what is there? Here electrons are the minority charge carriers, right? So that will cross the barrier, and that a small current will be formed in this due to reverse biasing. So that will be in range of microampere. So here we can draw the diagram just like the previous case. Here the voltage is taken along x-axis and current along y-axis. So here we can see the difference. In forward biasing we were getting milliampere current, and then in this case we are getting the microampere current here. So this is the microampere current, and here we are getting 0 as the current, and after the breakdown voltage only we are getting the current in the reverse direction. So this is the case of reverse biasing, and these two are very important, and hope it is clear to you. Now we can conclude the video. So if you like the video, please like, share and subscribe. Thanks for watching.